Ternary search. Ternary search is used to search for an element in a sorted array. It divides the array into 3 parts and searches for the key element in one of the 3 parts. Here is an example of a sorted array of length 7. Here, we need to search the index of key 21 from the array. The lower bound is set to 0 and upper bound is set to 6. We need to search for key equals 21. Now, we calculate mid1 and mid2 using the formulae given. We get mid1 equals to 2 and mid2 equals to 4. As ARR of mid1 is greater than key, we search in the first partition. So, UB equals mid1 minus 1. Again, we calculate mid1 and mid2 using the formulae given. We get mid1 equals to 0 and mid2 equals to 0. As ARR of mid2 is lesser than key, we search in the third partition. So, LB equals mid2 plus 1. Now, we have LB equals 1 and UB equals 1. We get mid1 equals to 1 and mid2 equals to 1. As ARR of mid1 equals to key, our search is successful and we return the index 1. Here is the code of ternary search in Python 3 language. It takes an array ARR, a key, a lower bound and an upper bound. While LB less than or equals to UB, run the while loop. In the while loop, calculate mid1 and mid2. If key equals ARR of mid1, return mid1. If key equals ARR of mid2, return mid2 and the function terminates. If key is less than ARR of mid1, assign UB equals to mid1 minus 1. If key is greater than ARR of mid2, we assign LB equals mid2 plus 1. In the else clause, we assign LB equals mid1 plus 1 and UB equals mid2 minus 1. If the control of the execution goes outside of the loop, we return minus 1 indicating search unsuccessful. The recurrence relation of the ternary search is T of n equals T of n by 3 plus C, T of n by 3 equals T of n by 9 plus C. In this way, we get many equations. On substituting all such equations, we get T of n equals T of n by 3 to the power k plus kc. If we take 3 to the power k equals n, we get k equals to log n base 3. Thus, our time complexity is big O of log n.